In this lesson, we are going to cover how to add and subtract polynomials. We are going to be working in section 5.4 in your textbook on page 444, and we are going to work problems 2 through 40 even. So to start off, we're going to look at number 2 in your book, and the problem says that you have 9x plus 3 and 3x minus 4. The directions simply tell you to add. So we are adding this entire quantity and this entire quantity. So we would represent that as saying we have 9x plus 3 plus 3x minus 4. So now that we have our problem set up, we can go ahead and see what we need to do to release those parentheses. There are 2 questions we need to ask. The first question is, can I combine my terms inside of my parentheses? The answer is no, because they are not like terms. Remember, in like terms, you have to have the same variables and exponents. So since this 3 does not have an x like the 9, they are not like terms. The second question you ask yourself, is there anything multiplying out in front? Technically, there is a 1 there, but if you multiply 1 into this set of parentheses, it won't change anything. So this 9x plus 3 can be released from the parentheses. So now, 3x minus 4. Ask the same 2 questions. Can I combine these 2 terms? No. Is there anything multiplying out in front other than that positive 1? No. So we can bring everything down. Now you can combine like terms. So I have 9x plus 3x is 12x. And then 3 minus 4 is negative 1. Number 4 says to add 2m squared plus 3m and 6m squared minus 8m. So remember, we are adding this quantity and this quantity. So we have 2m squared plus 3m plus 6m squared minus 8m. So now we ask our questions. Can we combine the 2 terms inside of this set of parentheses? No. Is there anything other than that positive 1 multiplying out in front? No. So it can be released. So we have 2m squared plus 3m. And then when we look over here, I've got 6m squared minus 8m. Can I combine my 2 terms? The answer is no. Is there anything multiplying out in front other than that 1? No. So we can release the 6m squared minus 8m from the parentheses as well. Now we combine our like terms. 2m squared plus 6m squared is 8m squared. And then 3m minus 8m is negative 5m. Remember that a term keeps the sign that's in front. So since that was a minus 8, that technically means that it is a negative 8. So your final answer is 8m squared minus 5m. Number 6, we have 9p squared plus 3p and negative 13p squared minus 3p. So now I'm going to put it in the set of parentheses. So I have 9p squared plus 3p plus negative 13p squared minus 3p. So now I ask my questions. Can these two terms inside of the parentheses be combined? The answer is no. And remember, the reason is because this p has a squared, this p has an understood 1. So in order for you to be able to combine those, they would have to have the same exponents. So you can't combine them, and there's nothing other than that 1 multiplying out in front, so it can be released. And then can I combine these two terms? No. Is there anything multiplying out in front? No. So I can release everything in this parentheses. Y'all might be thinking that those parentheses are kind of useless when we bring them from this original problem form into the actual expression. But when we work with subtraction here in a minute, this will make a difference. So I'm trying to get you guys into that habit now. So I have 9p squared minus 13p squared is negative 4p squared. And then I have 3p minus 3p, which is 0. So I just have negative 4p squared. Number 8, we have 4d squared minus 8d plus 7 and 5d squared minus 6d minus 9. So now I'm going to put my problem in those parentheses in that expression form. Just because there are 3 terms here does not change anything. It's still the same type of problem. So I have 4d squared minus 8d plus 7 plus 5d squared minus 6d minus 9. So now I need to see if I can release my parentheses. Can I combine any of the terms inside of that set of parentheses? The answer is no. Is there anything multiplying out in front? The answer is no. So they can be released from that parentheses. Same questions. Can I combine these terms? The answer is no. Is there anything multiplying in front other than that positive 1? No. So this can be released. So now I'm going to combine my like terms. 4d squared plus 5d squared is 9d squared. 8d, or it's a negative 8d, sorry about that, minus 6d is negative 14d. And then my 7 minus 9 is negative 2. Oops. So now we're going to work number 10. Number 10 says we have 4x minus 3 and 3x squared minus 9x. So to start, we're going to put this in our parentheses form. And now we're going to see if we can release them. Can I combine these two terms? No. Is there anything multiplying out in front other than that 1? No. So we can release the 4x minus 3. Can I combine these two terms? The answer is no. Is there anything multiplying out in front other than that 1? No. So we can go ahead and release this from the parentheses. So now let's go ahead and look at our like terms. They got really tricky on us on this problem, so make sure that you pay attention here. Well, I look for my highest exponent because if we remember what we learned about descending order in the section 5.3 notes on Intro to Polynomials, we know descending order starts with your highest exponent. Well, here, the highest exponent they put in the middle of the problem, and there is no other x squared term. So we know that just 3x squared is going to go in the front. Then I have a 4x minus a 9x is a negative 5x. And then I just have that negative 3. Number 12 looks a little bit different than what we're used to. We have 9x to the 4th minus 2x squared plus 2x squared plus 3. Well, if you notice in all of the other problems we've done previously, they gave us that word and in between the two expressions. And we had to put it in this parentheses form. So you could say that they actually have done us a favor and done the first step for us. So we don't have to write it in the parentheses form, and we can go ahead and try and release those parentheses. Can I combine these two terms? The answer is no, they are not like terms. Is there anything other than that 1 multiplying out in front? The answer is no. So this 9x to the 4th minus 2x squared can be released. And now over here, can I combine these two terms? No. Is there anything multiplying out in front other than that 1? No. So I can release those parentheses. So now I have my 9x to the 4th. And then notice I've got negative 2x squared plus 2x squared. Well, they're going to cancel out because negative 2 plus 2 is 0. So that's gone. And then we just have our plus 3 left over. Number 14, we have 9m to the 3rd minus 2m. Plus negative 6m minus 4m to the 3rd. So I can go ahead and release these from the parentheses. Can I combine these two terms? The answer is no. Is there anything multiplying out in front? The answer is no, not other than that 1. So I can release this from the parentheses. Now, can I combine these two terms? No. Is there anything multiplying out in front other than that 1? No. So I can release these parentheses. Oops. So now I'm going to combine my like terms. I'm going to start with my highest exponent, which is the m to the 3rd. So I've got 9m to the 3rd minus 4m to the 3rd is 5m to the 3rd. And then negative 2m plus negative 6m is negative 8m. Number 16. I have 5b to the 3rd minus 8b plus 2b squared plus 3b squared minus 7b to the 3rd plus, oops, Just making sure I wrote everything down correctly because this was kind of a tricky problem to write. Okay, so now I can work on releasing my parentheses. Can I combine any of my terms inside of this first set of parentheses? The answer is no. Is there anything other than that 1 multiplying out in front? The answer is no. So I'm going to go ahead and release this from the parentheses. So I have 5b to the third minus 8b plus 2b squared. And then, can I release any of this from the parentheses? The answer is, or can I combine any of these terms actually? Okay, the answer is no. Is there anything multiplying out in front other than the 1? No. So I can go ahead and release these from that set of parentheses. So now I'm going to combine my like terms. Again, I start with my highest exponent. And remember, the reason we're doing this is because we need to write our answer in that descending order like we learned in 5.3. So 5b to the third minus 7b to the third is negative 2b to the third. Then I have negative 8, oops, actually that's not my next to highest one. Next to highest one would be my 2b squared plus 3b squared is 5b squared. Then I have my negative 8b and my positive 5b, which would give me that negative 3b. We are finished. Now to move on to number 18. The directions in this section say to remove the parentheses in each expression and simplify if possible. So I've got the opposite of 7x minus 4y. Well, we know what we need to say in order to release something from parentheses. We have 2 questions to ask. The first question is, can I combine these 2 terms? The answer is no, they are not like terms. Next, is there anything multiplying in front other than that 1? The answer is yes. Because of that negative there, it's understood that this is an invisible 1, okay? So that means negative 1 times, because it's right next to that set of parentheses, it means you're multiplying negative 1 times everything inside. So we have to distribute that negative 1. So I'm left with negative 7x, because negative 1 times 7x is negative 7x. And then negative 1 times negative 4y is positive 4y. We cannot combine these terms in the end, so we are finished. Now to look at number 20, I've got 8x minus 2y minus 5z. So to release the parentheses, can I combine these 2 terms? The answer is no. Is there anything multiplying out in front? Yes. That is understood to be a negative 1, so we have to distribute that negative 1 into everything inside of that set of parentheses. Now we never once mentioned that 8x, so that wasn't included, so we just need to bring it down. So I have the 8x, and then negative 1 times 2y is negative 2y. Negative 1 times negative 5z is a positive 5z. We cannot combine any of these terms, so we are finished. Now number 22, we have 10m minus 3m minus 2n. So, can I combine these 2 terms in that set of parentheses? The answer is no. Is there anything multiplying out in front? Yes. Because of that negative, there's a negative 1. So we're going to distribute that negative 1 into each term inside of that set of parentheses. So the 10m wasn't mentioned, so we're going to bring that down. Negative 1 times 3m is negative 3m. Negative 1 times negative 2n is positive 2n. Now we ask, can we combine any of these terms? The answer is yes this time, because we've got a 10m minus 3m, which is 7m, and then bring your 2n over. And it does matter which term comes first, because we need that in that alphabetical order. So m comes before n in the alphabet. Number 24, we have 8d minus negative 7c minus 2d. Can I combine my terms inside of my parentheses? The answer is no. Is there anything multiplying out in front? The answer is yes, because it's a negative 1. So I'm going to distribute that negative 1 into each term inside of that set of parentheses. So the 8d was not mentioned, so we just bring it down to the next line. And negative 1 times negative 7c is a positive 7c. Negative 1 times negative 2d is a positive 2d. And now we need to see if we can combine any of these terms. Well, alphabetically, the 7c comes first. So we're going to go ahead and write 7c in our answer. But we have an 8d and a 2d. Those are like terms, so we can combine them. 8 plus 2 is 10. So our answer is 7c plus 10d. Okay, moving on to a new set of instructions. So on numbers 26 through 40, the directions simply say to subtract. Well, these are a little trickier than the addition problems. I've got 5x plus 1 from 7x plus 8. So if I were to say I wanted to take $8 from $20, you would say, well, your answer is 12, because 20 minus 8 is 12. That's how we would get $12. So notice when we did this problem, these two numbers actually changed and they kind of swapped places when we put them in that expression form. So that's what we have to do here. Okay? So we actually write this first, and then we write this second. So we will have 7x plus 8 minus, because we're subtracting, 5x plus 1. So your first thing should always be to write this in that parentheses form if it isn't already written there. So now, hold on one second, sorry about that. So now, can I combine these terms? No. And is there anything multiplying in front other than that positive 1? No. So we can go ahead and release the 7x plus 8 from the parentheses. Now, can I combine these two terms? No. Is there anything multiplying out in front other than that positive 1? Yes, because it's a negative 1. So we have to distribute that negative 1 into each term inside of that set of parentheses. So negative 1 times 5x is negative 5x. Negative 1 times positive 1 is negative 1. Now we can go ahead and combine those like terms. So 7x minus 5x is 2x. And then 8 minus 1 is 7. We have 9a squared minus 5a from 11a squared minus 10a. So now we have to write that in that parentheses form. So remember, we write this first and this second. So I'm going to have 11a squared minus 10a minus 9a squared minus 5a. So now I ask my two questions. Can I combine these two terms? The answer is no. Is there anything multiplying out in front other than that 1? The answer is no. So I can go ahead and release that 11a squared minus 10a from the parentheses. Then, can I combine these two terms? No. Is there anything multiplying out in front? Yes. It's a negative 1, and this is how it's going to be for all of subtraction. So I'm going to distribute that negative 1 into both sets of parentheses. So negative 1 times 9a squared is negative 9a squared. Negative 1 times negative 5a is positive 5a. So now we are going to work on combining our like terms. So 11a squared minus 9a squared is 2a squared. And then negative 10a plus 5a is negative 5a. Now moving on to number 30, we have 9n squared minus 4n from 7n squared minus 4n. So we need to write this in that parentheses form. So remember, we are going to write this first and this second. So I have 7n squared minus 4n minus 9n squared minus 4n. Now, can I combine these two terms? The answer is no. Is there anything multiplying out in front other than that 1? The answer is no. So I can release that 7n squared minus 4n from that set of parentheses. Next, can I combine these two terms in my second set of parentheses? The answer is no. Is there anything multiplying out in front? The answer is yes. So I'm going to distribute that negative 1 into both terms inside of that set of parentheses. So negative 1 times 9n squared is negative 9n squared Negative 1 times negative 4n is positive 4n. So now I can combine my like terms. So 7n squared minus 9n squared is negative 2n squared. And then negative 4n plus 4n, those terms will cancel. So we are just left with that negative 2n squared. Number 32 says we have 3x squared minus 2x plus 4, and we're subtracting that from 5x squared minus 8x minus 3. Guys, I'm going to adjust. It seems like it's kind of bright on this. I'm just going to adjust this just a little bit, just to see if that helps a little. Oops. I feel like that may have helped. Okay, so remember this is written second and this is written first. So I have 5x squared minus 8x minus 3 minus 3x squared minus 2x plus 4. So can I combine my terms inside of my set of parentheses? The answer is no. Is there anything multiplying out in front? The answer is no. So I have 5x squared minus 8x minus 3. Then, in the second set of parentheses, can I combine my like terms? The answer is no. Is there anything multiplying out in front? The answer is yes, it's a negative 1. So I'm going to distribute that negative 1 into all of those terms. So negative 1 times 3x squared is negative 3x squared. Negative 1 times negative 2x is positive 2x. Negative 1 times 4 is negative 4. Now I'm going to combine my like terms. So I have 5x squared minus 3x squared, which is 2x squared. I've got negative 8x plus 2x is negative 6x. And then I have negative 3 minus 4 is negative 7. Moving on to problem number 34. I have 3x to the third plus x squared subtracted from 4x to the third minus 5x. So I'm going to write this in my first parentheses, and this in my second parentheses. So I have 4x to the third minus 5x minus 3x to the third plus x squared. So can I combine the two terms inside of the parentheses? The answer is no. And is there anything multiplying out in front? The answer is no. So I can release that 4x to the third minus 5x from that set of parentheses. Then, can I combine these two terms? The answer is no. Is there anything multiplying out in front? The answer is yes, it's a -1. So I'm going to distribute that -1 into each term in that set of parentheses. So -1 times 3x to the third is -3x to the third. And then -1 times x squared is -x squared. Now I combine my like terms. I have a 4x to the third minus 3x to the third is just x to the third. If you wrote the 1 in front of here, that would be okay. It's no problem. Then my next term would be my -x squared. It doesn't have any of the like terms. And neither does that -5x. It's very easy to forget those negatives, so really be careful with that, guys. Okay, number 36. 36 is a little different than what we're used to seeing. We have 3y squared minus 2y minus 7y minus 3y squared. So on this, we don't have to switch anything. We always had to switch it because it said we're subtracting this from this. So again, with my example, if we had $8 from 20, then you would translate that to be 20 minus 8, which is $12. So before, they were giving you the problem in this form. But now on number 36, they are giving you the problem already switched around in this form. So now, it's like they already gave it to us at this step. So we could say thank you. So we can go ahead and release our terms from the parentheses by asking our two questions and work on solving. So I've got 3y squared minus 2y. Can I combine these two terms? No. Is there anything multiplying out in front? Not other than the 1. So I'm left with 3y squared minus 2y. Then, can I combine these two terms? The answer is no. And is there anything multiplying out in front? Yes, the answer is that -1. So we are going to distribute that -1 into everything in that set of parentheses. -1 times 7y is -7y. -1 times -3y squared is +3y squared. So now I'm going to combine my like terms. I have 3y squared plus 3y squared, which is 6y squared. And then I have -2y minus 7y, which is -9y. Number 38, I have 4x to the third plus x minus 3x squared minus 4x minus 2x squared plus 4x to the third. So I can't combine any of my terms inside of my set of parentheses because none of them are like terms, and there's nothing multiplying out in front. So I can go ahead and release everything from that set of parentheses. So that gives me 4x to the third plus x minus 3x squared. Then, can I combine any of these terms? The answer is no. Is there anything multiplying in front? Yes, the answer is a -1. So I can distribute this -1 into this set of parentheses. So you distribute that into each term. So -1 times 4x is -4x. -1 times -2x squared is positive 2x squared. -1 times 4x to the third is -4x to the third. So now we can combine our like terms. 4x to the third minus 4x to the third, well, those cancel out because they give you 0. -3x squared plus 2x squared is -x squared. If you wrote -1x squared, that would be fine. And then x minus 4x is -3x. The integers on that problem were pretty nasty, so be careful on that one. Now moving on to number 40. This is the last problem of this lesson. We have 4x minus 8x to the third plus x squared minus 6 minus 5x to the third plus 4x to the fourth plus 4x. So can I combine any of these terms in my parentheses? The answer is no. Is there anything multiplying out in front? The answer is no. So we have 4x minus 8x to the third plus x squared. Can I combine any of these terms? The answer is no. Is there anything multiplying out in front? Yes, it's a -1. So I'm going to distribute that -1 into each term in that set of parentheses. So -1 times 6 is -6. -1 times -5x to the third is positive 5x to the third. -1 times 4x to the fourth is -4x to the fourth. -1 times 4x is -4x. Now I've got a -8x to the third and a 5x to the third, which gives me -3x to the third. But we missed that -4x to the fourth, because remember, we should always start with the highest exponent to put it in that descending order. So that -4x to the fourth just goes in front of the 3x to the third. So then I have an x squared all by itself, so that would just be plus x squared. And then I have a 4x minus 4x. Those terms will cancel. And then we just have that -6 left over. And that is our final answer. I hope this lesson has been beneficial to you. I wish you the best of luck.